Hello Internet, welcome to another topic in data and computer networks. We'll talk about error detection and correction codes, and in that series we are covering CRC, which is acronymed as Cyclic Redundancy Check. If you've seen my previous video, in that video we've discussed checksum. Now checksum is based upon binary addition with 1's complement and 2's complement involved. However, cyclic redundancy check is based upon binary division. Although CRC is pretty basic, but it makes a lot of sense because the overhead per payload is very improved in CRC as compared to Hamming code or any other EDC method we may take up. As far as the algorithm is concerned, the algo of CRC is pretty simple. We take up an m-bit data and we append it with certain number of zeros, and a divisor is taken up of n plus 1 bits, and division is carried out, the remainder is obtained, and n bits of remainder is then attached to the data as the additional information required to check whether there is an error in the signal or not. So this becomes our payload and this becomes our overhead, and this is obviously transmitted to the receiver, and the receiver gets data plus its overhead, which is CRC in this case. And this divisor that we take up at the transmitter, is the information of that divisor is given to the receiver prior to starting up the transmission. So that divisor is again used to divide this entire m plus n bit of data, and that should give us a remainder as 0 if no error is there, because we found the remainder here and we attached the remainder with the data. Now at the receiver end, when we divide the entire thing with the same divisor, it should give us a remainder 0. And finally, at the end of this algorithm, if the remainder obtained is 0, we accept the data as error free data, otherwise we reject it as an erroneous data. Now we'll take up an example where we'll wish to send 101 0000 as the original message, and we'll take up the divisor to be 1001. So the first step will be to divide this, and by the way, we will add 3 additional bits here, which are we need to add n zeros with m bits of data. So what we have here is we get a 1 0 0 1 and we XOR it. I'll put a @ sign for XOR, so I get a 1 1 here and followed by too many zeros, 6 zeros to be precise, and then I'll do an XOR again with 1 0 0 1. What I get is 1 0 1 followed by 4 zeros. Then I do an XOR again with 1 0 0 1, and what I'm getting now is a 1 1 followed by 3 zeros. I do a XOR again. I get 1 0 1 0, and I do an XOR again, and all my digits are consumed, so I'm left with 0 0 1 1. Now what we need to do is we need to take out n bits from the remainder as suggested by the algorithm. So we'll take up these 3 bits and we'll put it next to the data as CRC. So the data which I will transmit, or you could note down it as message to be transmitted, it becomes equivalent to 1 0 1 0 0 0 0 0 0 0, but we'll replace it with 0 1 1. So the final message that goes out of the transmitter is this. Now at the receiver end, what happens at the receiver end? We will receive this data, let us say, which is error free, and if we divide it with the same divisor, because the information of the divisor will already be present with the receiver as a generator polynomial. So the generator polynomial will tell us that the divisor is 1 0 0 1. We always need to use this divisor. So if we start dividing this with the generator polynomial's divisor, what we expect to get is a 0 at the end, because this is what was expected out of the CRC algorithm. So we have a 1 1 here followed by 0 1 1, and we have 1 0 0 1, 1 0 0 1, and finally that goes off as all zeros. And a 0 means that we are going to accept this data. We are going to accept this data as error-free data. So that is how cyclic redundancy check works. We append our data, we add additional payload, which is kind of calculated as a remainder using this method. And I hope this tutorial on CRC as a tool to check whether error is present or not. By the way, had this data been any other data, if even one bit of data changes, then you would never ever get a remainder as 0 here. So if the remainder is a non-zero thing, that means that some bit has changed. So extremely useful and extremely accurate. CRC is used in a lot of frames in computer networks. When you'll study data link frames, you'll find CRC being used in many frames. So thank you so much for watching this video. You have a good day, good life ahead. Bye.